Today we will solve examples from the chapter differentiation in that exercise 1.1. The first example is differentiate with respect to x cube minus 2x minus 1 bracket raised to 5. We have to differentiate this function with respect to x. Let y is equal to x cube minus 2x minus 1 bracket raised to 5. So differentiating with respect to x, what we get, dy by dx is equal to, now we have to differentiate this function with respect to x. Now as it is a composite function, we cannot differentiate it directly. So we have to treat, you have to use the chain rule. How to use the chain rule? This is our f of x. What is this? X cube minus 2x minus 1. This is our f of x. So this function becomes f of x raised to 5. Now how to find the derivative of f of x raised to 5? It is 5 times f of x raised to n minus 1. That means 5 minus 1 into f dash of x. F dash of x means d by dx of x cube minus 1 minus 2x minus 1. So the 5 times x cube minus 2x minus 1 bracket raised to 5 minus 1 is 4 into d by dx of this x cube minus 2x minus 1. Now how to find the derivative of these? We will separately find the derivative. Derivative of x cube minus 2 times 2 is constant, so we can take outside the derivative. So 2 into derivative of x minus derivative of 1. Now derivative of x cube is our standard function, x raised to n. Its derivative is n times x raised to n minus 1. So here you get the derivative 3 times x square minus 2 into derivative of x is 1 and 1 is constant here, 1 is constant, so its derivative is 0. So you get dy by dx is equal to 5 into x cube minus 2x minus 1 bracket raised to 4 into 3x square minus 2. Just then you get, so we get dy by dx is equal to 5 in bracket 3x square minus 2 into x cube minus 2x minus 1 bracket raised to 4. Now the second example is 2x raised to 3 by 2 into 3x raised to 4 by 3 minus 5 bracket raised to 5 by 2. Now this function is not having any name, so we will write it as y. We will give it the name as y. Y is equal to 2x raised to 3 by 2 minus 4x raised to 4 by 3 minus 5 bracket raised to 5 by 2. Now differentiate with respect to x. Again, it is a composite function, so we will treat this bracket as our f of x. Then f of x raised to n, its derivative is given by n times f of x raised to n minus 1 into f dash of x. F dash of x means the derivative of this bracket. So in next step we will find the derivative of this. So 2 as it is, derivative of x raised to 3 by 2. Then 3 as it is, derivative of x raised to 4 by 3 and minus derivative of 5. Now here in both the cases we use the formula d by dx of x raised to n is n times x raised to n minus 1. So n times means 3 by 2 times x raised to n minus 1. So 3 by 2 minus 1. 3 by 2 minus 1 is 1 upon 2 and 4 by 3 minus 1 is 1 upon 3. So we get this derivative as dy by dx is equal to 5 upon 2 3x raised to, this 2 will get cancelled, this 3 will get cancelled, and what will remain? 3x raised to 1 upon 2 minus 4x raised to 1 upon 3 into this bracket 2x raised to 3 by 2 minus 3x raised to 4 by 3 minus 5 raised to 3 upon 2. This is the derivative of the given function. The next example is differentiate with respect to x, square root of x square plus 4x minus 7. Let y is equal to square root x square plus 4x minus 7. Now we know how to differentiate root x, but here there is a composite function root of x square plus 4x minus 1. So we will treat this x square plus 4x minus 1 as f of x. So it becomes y is equal to root f of x and its derivative. We know that how to find the derivative of root f of x. It is 1 upon 2 root f of x, 1 upon 2 root f of x into f dash of x means derivative of that f of x. So d by dx of x square plus 4x minus 7. So d by dx of x square plus d by dx of 4x minus d by dx of 7. Now derivative of x square is 2x because it is 2 raised 2 times x raised to 2 minus 1 and 2 minus 1 is 1. So 2x and d by dx of x is 1 and d by dx of 7, it is a constant function, so its derivative is 0. So simplify it, we can take write 2x plus 4 upon 2 times under root x square plus 4x minus 7. So if you take the 2 common from this, it will cancel the denominator 2 and you get x plus 2 upon a square root of x square plus 4x minus 7. Moving further, differentiate with respect to x, square root of x square plus root x square plus 1. Now let y is equal to square root of x square plus root x square plus 1 composite function. So we will treat as root f of x. So 1 upon 2 root f of x into f dash of x. So d by dx of the whatever the quantity which are present in the square root. So x square plus root x square plus 1. X square plus root x square plus 1. We will take the derivative of this function. Now how to take? We will differentiate the first x square and then add with the derivative of this root x square plus 1. Now the derivative of x square is 2x and derivative again here we have to use the formula root f of x, square root of f of x. Its derivative is given by 1 upon 2 root f of x into f dash of x. F dash of x means d by dx of x square plus 1. Now it's d by dx of x square plus 1. Its derivative is 2x and derivative of 1 is 0. So 2x plus 0. Here this 2 and this 2 will get cancelled to each other. Then here is also x. Here is also x. So we can take x common. So we get this is this step. Now further, if we take the LCM of these two terms, then 2 into square root of x plus 1 or multiply divided by 2 here, multiply divided by square root of x square plus 1, you will get this equation. So this is the derivative of the function. The next example, differentiate with respect to x. 3 upon 5 into fifth root of fifth. No, there is a third root. Cube root of 2x square minus 7x minus 5 bracket raised to 5. We will say this as y. Y is equal to something. So differentiate, or here we will simplify it. Okay, we will take it in the numerator. So this is 3 and this 5, we get 3 upon 5. Now this is cube root of 3, cube root of something. So it is bracket raised to 1 upon 3. Bracket raised to 1 upon 3. And already there is raised to 5. So it becomes 2x square minus 7x minus 5 bracket raised to minus 5 upon 3. Because we are taking it in the numerator. Now differentiate with respect to x. Here 3 by 5 is constant. So we can take outside the derivative. This is our f of x. F of x raised to n is n times f of x raised to n minus 1. N times f of x raised to n minus 1 into d by dx of f of x. Now d by dx of 2x square minus d by dx of 7x minus d by dx of 5. So 2 we can take outside, then d by dx of x square, 7 times d by dx of x and d by dx of 5. The derivative of x square is 2x, derivative of x is 1 and derivative of 5 is 0. So what you get after simplifying, minus 2x square minus 7 x minus 5 raised to minus 8 upon 3 into 4x minus 7. Here this 3, 3, 5, 5 gets cancelled and we will get this answer. 7 minus 4x upon 2x square minus 7x minus 5 bracket raised to 8 by 3, because we have written it in the denominator. So this minus sign will get cancelled. The next example is square root of 3x minus 5 minus 1 upon square root of 3x minus 5 bracket raised to 5. Let y is equal to the given function. Then we have to differentiate with respect to x. Now this, whatever the quantity is present in the bracket, it is our f of x. So f of x raised to 5. Its derivative is 5 times f of x raised to 5 minus 1 is 4. So 5 times f of x raised to 4 into f dash of x. 5 times f of x raised to 4 into f dash of x. F dash of x means derivative of this minus derivative of this. Again, so we can simplify it. Derivative of 3x minus 5 raised to half. Square root means raised to half minus derivative of this, but it is in the denominator. If we take it in the numerator, its index will be minus 1 upon 2. So what is the derivative of this? Again, here we used f of x raised to n is n times f of x raised to n minus 1. So 1 upon 2 minus 1 is minus 1 upon 2 into f dash of x. F dash of x means 3x minus 5. It's the derivative. It is derivative of 3x is 3. Derivative of minus 5 is 0. So what you get? 3. Similarly, differentiate 3x minus 5 raised to minus 1 upon 2 with respect to x. You get this. So after simplifying, 5 times bracket root 3x minus 5 minus 1 upon root 3x minus 5 bracket raised to 4 into 3 by 2 in bracket 3x minus 5 raised to minus 1 upon 2 plus 3x minus 5 raised to minus 3 upon 2. Now, so what you get? This 3 upon 2 and this 5 is, you get 15 upon 2. And here 3x minus 5 raised to minus 1 upon 2 can be written as 1 upon root 3x minus 5. And this 3 by 2 can be written as in the denominator, and we will split it into the 1 plus 1 upon 2. 1 means 3x minus 5 raised to 1 and 1 upon 2 means square root of 3x minus 5. Now here there is lack of only 3x minus 5. So if you multiply divided by 3x minus for this step, okay, then you will get 3x minus 5 plus 1 upon 3x minus 5 in root 3x minus 5. Again simplifying it, you get 3x minus 5 plus 1 is 3x minus 4, and this is as it is. So again we can write it in the form of raised to 4. So this is the derivative of the given function. Next, differentiate cos of x square plus a square. Let y is equal to cos of x square plus a square. Now differentiate with respect to x. Now what we will do here, dy by dx is equal to cos of f of x is our function. Cos of f of x. So what is the derivative of cos? Its derivative is minus sign. So minus sin f of x is the derivative into d by dx of derivative of f of x. So d by dx of x square plus a square, because we are treating this function as cos of f of x, because already we have studied, we have noted this formula in the first lecture. D by dx of cos f of x is minus sin f of x into f dash of x. So this will as it is, and d by dx of x square plus d by dx of a square. Now d by dx of x square is 2x and d by dx of a square. A is a constant, so its derivative is 0. So what you get? Minus 2x into sine of x square plus a square is the derivative of the given function. The second example is under root e raised to 3x plus 2. E raised to 3x plus 2 plus 5. So let y is equal to under root e raised to 3x plus 2 plus 5. So differentiate with respect to x. Here again we will treat this function as root f of x. So what is the derivative of root f of x? It is 1 upon 2 root f of x into f dash of x. Okay. So we have to differentiate this e raised to 3x plus 2 plus 5. How to? Take the separate differentiation. In that separate differentiation, again we will treat this as e raised to f of x. Now derivative of e raised to f of x is e raised to f of x into f dash of x. So e raised to f of x into f dash of x means derivative of 3x plus 2 and derivative of this 5. So but the derivative of 5 is 0 and derivative of 3x plus 2 is 3 into 1 plus 0, that means 3. So e raised to 3x plus 2 into 3 plus 0. So what you get? Dy by dx is equal to 3 upon 2 into e raised to 3x plus 2 divided by square root of e raised to 3x plus 2 plus 5. Our next example is differentiate with respect to x log of tan x by 2. Now here there is a combination of three functions. So log is there, tan is there, x by 2 is there. So let y is equal to log of tan of x by 2. We have to differentiate this with respect to x. So dy by dx is equal to log of f of x. So what is the derivative of log of f of x? It is 1 upon f of x into f dash of x. So 1 upon f of x means 1 upon tan x by 2 into f dash of x means d by dx of tan x by 2. Now here again I will use formula tan f of x. Derivative of tan f of x is sec square f of x into f dash of x. So sec square f of x into f dash of x means x by 2, it's a derivative. So derivative of x by 2 is 1 upon 2 and 1 upon tan is cot. In next step I will write this cot as cos upon sine and this sec as 1 upon cos square. So here there is one cos, here there is two cos. So one of them is cancelled and what you will get 1 upon 2 sine x by 2 cos x by 2, which implies sine x, because here we have used the formula sine 2 theta is equal to 2 sine theta cos theta. So which implies the derivative of the given function is cosec x. Our next example is differentiate with respect to x root tan root x. Let y is equal to square root of tan root x. Now again we will use the chain rule. Differentiating with respect to x, dy by dx of this, we treat this as root f of x. So derivative of square root of f of x is 1 upon 2 root f of x into f dash of x. 1 upon 2 root f of x into f dash of x. So what you get? F dash of x means tan of root x, its derivative. Here again I will use the chain rule. D by dx of tan x means d by dx of tan f of x. Now tan f of x, its derivative is sec square f of x into f dash of x. Sec square f of x into f dash of x. So f dash of x means d by dx of square root of x. Then root x, its derivative is 1 upon 2 root x. Put those values in this equation. Simplify it, you get sec square root x. This 2 into 2 is 4 root x and this root tan root x will combine together and you will get x tan root x. Now the next example is cot cube of log x cube. Let y is equal to cot cube of log of x cube. Now instead of keeping a log of x cube, I will simplify it in this quart cube of 3 log x, because log of x raised to n is n times log x. Now then we differentiate with this. Now here I will treat this function as f of x its cube. Now derivative of f of x its cube is 3 times f of x raised to 3 minus 1 into f dash of x. So 3 times quart square of 3 log x into d by dx of quart of 3 log x. Now how to find the derivative of this? So it is quart f of x. Derivative of quart f of x is minus cosec square f of x into f dash of x. So f dash of x means d by dx of this 3 log x. Now but 3 is a constant, so we can take outside the derivative, and log x its derivative is 1 upon x, so you get the derivative 3 upon x. Now after simplifying it, what you will get? This 3 in this 3 into 3 is 9, minus 9 quart square of 3 log x into cosec square of 3 log x into 1 upon x. Then we simplify it and we convert our answer into the given format. Instead of writing 3 log x, I will write log of x cube. Now differentiate with respect to x 5 raised to sine cube of x plus 3. Let y is equal to 5 raised to sine cube of x plus 3. Differentiate with respect to x. Here this sine cube x plus 3 is our f of x. So this function is in the form of f of 5 raised to f of x. 5 raised to f of x. So its derivative is given by 5 raised to f of x into log of 5 into f dash of x. 5 raised to f of x into log of 5 into f dash of x. F dash of x means derivative of the given function. So now how to find the derivative of this? So d by dx of sine cube plus d by dx of 3. 3 is a constant, its derivative is 0. So the derivative of d by sine cube x, its derivative is, again this we will treat this function as f of x its cube. Its derivative is 3 times f of x raised to 2 into f dash of x. So dy by dx is equal to 5 raised to sine cube x plus 3 log of 5 into 3 sine square x into derivative of sine x is cos x. So this is the derivative. Dy by dx is equal to 3 log 5 into 5 times log 5 raised to sine cube x plus 3 into sine square x into cos x. Now differentiate with respect to x cosec. So differentiate with respect to x cosec of root cos x. Let y is equal to cosec root cos x. So the differentiating with respect to x, we will treat this function as cosec of f of x. Now what is the derivative of cosec f of x? Is minus cosec f of x into cot f of x f dash of x, minus cosec f of x cot f of x into f dash of x. F dash of x means d by dx of root cos x. Now how to find d by dx of root cos x? It is root f of x, its derivative is 1 upon 2 root f of x into f dash of x. So d by dx of f of x is cos x. So what is the derivative of cos x? Is minus sine x. So simplify it, you will get this minus and this minus will get cancelled to each other, and what you get, sine x cosec root cos x cot root cos x into 1 upon 2 root cos x. So this is the derivative of this function. Now differentiate with respect to x, the third one, log of cos of x cube minus 5. Let y is equal to log of cos of x cube minus 5. Then here we treat this function as f of x. So what is given in, always think in your mind to find, to use the chain rule. How to use? We treat this function as log of f of x. What is the derivative of log of f of x? It is 1 upon f of x into f dash of x. So dy by dx is equal to 1 upon cos of x cube minus 5 into d by dx of cos of x cube minus 5. Again, here finding the derivative of cos of x cube minus 5, we will use the composite function cos f of x. Now, what is the derivative of cos f of x? Is minus sin f of x into f dash of x. Minus sin f of x into f dash of x. D by dx of x cube minus 5. So, d by dx of x cube minus 5 means d by dx of x cube minus d by dx of 5. But 5 is a constant, its derivative is 0. So what you get? The derivative of x cube only. So it is 3 times x square. So simplify rewriting it, you get dy by dx is equal to minus sin x cube minus 5 upon cos x cube minus 5 into 3x square. But here sin upon cos, they are having the same angles. So sin upon cos is a tan. So minus 3x square into tan of x cube minus 5. This is the derivative of the given function.